Hey guys, so today we're going to be starting our properties of exponents, and today we're going to be focusing on multiplication. So the first thing that we're looking at today is a word problem, and it says the Bab family is moving, and Mr. Bab has several cube-shaped moving boxes that measure 5 feet along each edge. The volume of one moving box can be expressed using the exponent below. We are going to label the parts of the exponent and write it in its expanded form and then simplify. So, when we're talking about an exponent or a number or a variable raised to an exponent, we refer to it as the base. So, again, this larger number is the base, and the smaller number is the exponent. So when I expand this, what this is telling me is that I'm going to have 3 of the 5s. So 5 times 5 times 5. So to simplify this, I just multiply them together, and we can use Desmos for that. So if we go to Desmos, I have 5 times 5 times 5, which is 125. And again, I apologize for the delay. Now, understanding exponent properties will help us simplify numeric and algebraic expressions. In A and B, we're going to write the expanded form of the product, then express the product as a single base raised to an exponent. So let's expand A first. So I have 4 squared, which is 4 times 4. And then I have 4 to the 5th, which is, again, 4, 4. I have 5 fours, essentially. So when it wants us to express this as one single problem, what I'm going to do is count all of the 4s that were given. So I have 1, 2, 3, 4, 5, 6, 7. So ultimately we have 4 to the 7th power. Likewise, in part B, we have n cubed. So that's 1, 2, 3 n's. And then another set of 3. 1, 2, 3. And when we count all of these together, so again, 3 and 3, we count them together, we get n to the 6th. So describe any patterns we noticed about the examples above. So the main pattern that we focused on is that if I think about it, 2 and 5 make 7, 3 and 3 make 6. So the main pattern that was expressed in these problems is going to be we added the exponents together when bases are being multiplied. Again, I apologize for the delay. I don't know why it's acting up. There we go. So again, we added the exponents together when bases are being multiplied. So off to the side, we have a little definition box that when we have product of powers, so product of powers, product meaning multiplication, a to the x times a to the y means that we are going to add exponents together. So in the examples below, we're going to apply the product of powers property to write each product as a single base raised to an exponent. So all we're going to do is like we did in the examples above. So all I'm wanting to do is write this as a single base. Again, when we multiply, we add them together. So I'll write this out for the first couple ones, and then you don't necessarily have to do it the better you get at it. So x to the 5th times x to the 12th, we're going to add our exponents together, which is x to the 17. Okay, for the next one, 9 to the 4 times 9 to the 4, so 4 plus 4, so we get 9 to the 8th. For the next problem, I don't really see an exponent right here with the first b, and if there is no number there, it's always an understood 1, just like everything else we do. It's always 1 if there's no number written. So b to the first and b to the second, 7th, 1 plus 7 equals b to the 8th. And lastly, I'm going to give you a few seconds to do the last one on your own, and then we'll talk about it. Okay, so for this one, I have my base is 3, and we have the exponents 3 plus 4 plus 5, and that gives us 3 to the 12th. So finally, when expressions contain different bases, group powers with the same base. So again, we're looking for the same base, and then we apply the product of powers property. And general rule of thumb is I always like to tackle the numbers first. So group your numbers together, then group everything with the same base together, and then we can simplify. It just makes it easier to look at. So if I look at number 5, I'm looking for basically common bases. So if it's a plain number, we have 3 and 5. We are going to multiply those two together. So we're going to group those, 3 times 5. And we'll simplify this once we group everything together. And then I have bases of x and x. So when we multiply, we add the exponents together. We have x to the 4th plus 5. So when we simplify this, 3 times 5 is 15. And then x to the 4 plus 5 gives us x to the 9th. And I'll give y'all a little bit just to get caught up because of the delay there. Next, we're going to try number 6 together. So I'm going to start off by grouping them with the numbers. We have 4 and 6. So I put it as 4 times 6 because we're still multiplying bases. Then x and x. We have x cubed and then x squared. Finally, for our y's, I have y to the first and y cubed. So I'm going to add 3. So 4 times 6 is 24. 3 plus 2 gives us x to the 5th. And then 1 plus 3 gives us y to the 4th. So I'm going to give you a few seconds to practice number 7 on your own. In the event that I do create this into a play posit, you'll type in your answer below. All right, so we're going to group this together. We have -2 times 8. Then I'm going to combine my a's. So I have a to the first and a to the second. So 1 plus 2. And then for this one, I only see one base with b. So what that means is b cubed is just going to drop down. It's like a leftover. It's not going to change, just kind of stays the same. So when we simplify this, we get -16 a cubed b cubed. And that would have been your final answer. So again, if there are no other matching bases, we're just going to bring our leftovers down. It's still part of the answer and does not disappear. So let's look at the next page. So in examples C and D, we're going to write the expanded form of the expression, then express the product as a single base. So this one is a different property that we're about to start talking about. And what we're going to do is working from the outside in. So similar to the distribution property, whatever's on the outside gets multiplied that many times. So for C, I see that there's a 3 on the outside. What this tells me is I'm going to have 2 squared times 2 squared times 2 squared. So I did that 3 times. And then if I wanted to expand it further, this is 2 times 2 times 2, 2, 2 times 2. Because that is 6 2's. So 2 to the 6th, if I was to go to Desmos and multiply it out, if I click on the little keyboard down here, we're looking for, so I'm going to type in my 2, a to the b. What that means is that I can type in any exponent that I need. So I'm going to type in 6, and that gives me 64. So 2 to the 6th is 64. And I'm going to show you that one more time. So in our little keyboard, you type in the base first. So whenever I come to the calculator, you have to use numbers only. You cannot type in your variable. So 2, AB, 6, and we get 64. For the next one, this is going to be slightly different. So I still have exponent on the outside is 2. So that means I'm going to have 4x squared times 4x squared. And just like we did before on the previous page, I'm going to group everything together. So 4 times 4. And then I have x squared, so x 2 plus 2. And when I finish solving this, 4 times 4 is 16. And then 2 plus 2 gives me x to the 4th. So that's two different ways that we can approach this power of a power and power of a product property. So describe any patterns you notice about the examples above. We distributed any exponents on the outside to the inside. Another thing that we can say is that we multiplied the exponents together. So when your exponents are side by side, we can multiply. So if I look at C again, 3 times 2 gives me 2 to the 6th, which matches what we solved in the beginning. So if I was to type C into Desmos, we were to type C into Desmos, just like it's written, I have parentheses 2 squared, and then I'm going to press my AB button and type a 3 on the outside. You can only do this with numbers. You cannot do it with variables. So what they did is they multiplied. So I have 2 squared, and they multiplied by 3. Hold on. So we it's not wanting to, hold on. So for this, I guess we have to use parentheses, so 2 times 3. So they multiplied the exponents together. So the main thing, I'm about to write it in blue. When exponents are side by side, you multiply. So the first one, if we have a power of a property, we just multiply the exponents. Similar to that distribution. So a to the x times y. And then whenever I have a power of a product, so there's more than one thing on the inside, both bases get the exponent. So I would have a to the x, b to the x. We have a little bit left and then we'll be done for today. So The next thing we need to look at is that when we apply properties of exponents to simplify each expression below, remember to group like. So group like bases and apply the property when necessary. So let's look at 8 first. So this one is going to be similar to your power of a power property. Power of a power property I'm going to show in blue. Power of a product I will show in purple. So 8 is going to be blue, and when exponents are side by side, we multiply. So x to the 7 times 3 is going to give us x to the 21. Because 7 times 3 is 21. Give it a second to catch up. There. So again, 7 times 3, 21. Then, where the next one, this is going to be power of a product property. So I'll do it in purple. We're going to distribute the 3 to every base. So I have 7 cubed, c cubed, d cubed. And this does ask us to simplify. So all we need to do is figure out what is 7 cubed. And I'm going to go to Desmos. So 7 cubed is going to give us 343. Again, you type in your base. So we type in the base, AB, exponent. So we get 343 c cubed d cubed. So let's practice 10 together, and then I'm going to see if you can do number 11 on your own. So 10 is a combination of both. Whatchamacallit? It's a combination of both. We're going to use power of power and power of a product. So I'm going to distribute. I have negative 12 squared. Make sure that with any negative exponent or negative bases, you put them in parentheses. If you do not, it will give you an incorrect answer. Then I have a to the 6th times 2. Then we have b to the 5th times 2. And the last one is technically c to the 1st. And I'll give my computer a second to catch up. And then I'll write it out. So again, a to the 6th times 2, b to the 5th times 2. Then I have c to the 1st times 2. So for negative 12 squared, this is 144. 6 times 2 is 12, so we have a to the 12th. 5 times 2 is 10, so b to the 10th. And finally, 1 times 2 gives us c squared. So go ahead and see if you can practice 11 on your own. I know it's hard, but you can do it. All right, so for number 11, I'm going to take this piece by piece. I'm going to work on the left side first and then the right side second, and then we will combine. So I'm going to distribute that square. So I have 4 squared, and then x to the 2 times 2, and y squared. When we simplify this, we get 4 squared is 16, x to the 4th, y squared. Okay, let's look at the next one. So with this one, you're only distributing the 4 to whatever's on the inside of the parentheses. So I'm going to bring down my 2, and I have y to the 3 times 4. When we simplify this, we get 2y to the 12th. So now what I can do is use that first property we learned about, the product rule. 16 times 2. Bring down your x to the 4th because it's all alone. And then I have y to the 2 plus 12. Because again, if we multiply bases, you add the exponents. Which leaves us with 32, because 16 times 2 is 32. X to the 4th, y to the 14th. So again, I know that this one was difficult, but as long as you attempted it, that's what I care about the most. All right, we have 4 examples left, and then we will be done with the notes for today. So in number 12, Melissa believes that the following expressions are equal for any value of b. Is she correct? So I'll give you a moment to look at this problem and determine, are these two equal? All right, so for these two problems right here, I see that there is multiplication, which is technically a product. So I know that technically I need to be adding these two together, which is not the same as multiplication. Because if I added them together, we get b to the 11th. And if we multiplied, we would get b to the 28th, which is not equal. So no, Melissa is not correct. For 13, the expression x to the 15th times x to the 6th raised to the 4th power is equivalent to x to the n. What is the value of n? So all they want us to do here is simplify. That's all it's asking us to do. So we're going to work this problem out together. First thing we need to do is get rid of the 4, or we need to get rid of the parentheses. So I'm going to distribute the 4 to the 6, which gives us, when we multiply, x to the 24. Bring down your x to the 15 because we're multiplying. Parentheses represent multiplication. So when I add these two together, 15 plus 24, gives us x to the 39. So the value of n is 39. All right, so Sanja simplified the following problem as shown. Identify Sanja's error and correct her work. So I'm going to give you a few minutes to figure out which step, 1, 2, or 3, did she get wrong. So go ahead and type your answer, 1, 2, or 3, in the box below. All right, so let's go ahead and look at this. So she starts off by distributing, in which she gets 3 cubed times x cubed. And then for the second one, she gets 3 to the 4th. And then she multiplies to get 8, which is correct. So x to the 8th. So step 1 is correct. The second step, she groups the like bases together. So we got 3 cubed and 3 to the 4th. And then she does x cubed, x to the 8th. So step 2 is correct, which leaves us with step 3. And if you notice, because we are multiplying, she should be adding her exponents together. So if we add exponents together, we should get 3 to the 7th and then x to the 11th. So step 3 is the incorrect step. And finally, for number 15, the area of a circle can be found using area equals pi r squared. We need to write an expression to represent the area of the circle with a radius of 5 x to the 7th y cubed. Leave your expression in terms of pi, meaning we do not have to turn pi into a number. So if we think about this in terms of pi r squared, our radius is this. So I'm going to plug this in place of r. So 5x to the 7th y cubed and square it. So the main thing I'm going to be focusing on here is this part. We're going to distribute the 2 to everything. Again, multiply your exponents together. So we get 5 squared x to the 14th y to the 6th. And if I want to simplify this further, 5 times 5 is 25, x to the 14th, y to the 6th. And lastly, bring down to pi. And this is the correct answer. So if you have any more questions, please email me right away. That way we can get those questions answered before I come back. There is a Delta Math assignment for you to complete. It should only be somewhere between 10 to 15 problems, and it will be due by next class period. Again, if you have any questions, please email me or go and talk to another algebra teacher. I hope to see y'all soon. Have a great day.